Hi everyone, I'm Whit Roy. Today I've invited an electrical tutor and an apprentice to have a conversation as they go through topics from the EWRB Electrician Theory exam. I hope you enjoy this style of learning.
Alright, today we're reviewing basic electrical theory. This topic's all about how electricity behaves, how energy changes form, and how we understand voltage, current, resistance, and simple circuits. It's the foundation for nearly everything else in electrical work.
Yep, this is the one that everything seems to come back to in the exam.
Exactly. So we'll take it slow and just focus on the key ideas. First up, electrical energy can change into different forms depending on what the appliance is doing.
Right, like heaters and motors?
Yep, the first one is heat energy. When current flows through resistance, it produces heat. That's how heaters, kettles, ovens, and toasters work.
So if more current flows, you get more heat.
That's right, and that's also why overloaded cables overheat. Next is chemical energy.
That's batteries, yeah?
Yep, batteries store energy chemically. When you charge a battery, electrical energy turns into chemical energy. When it discharges, the chemical energy turns back into electricity.
Okay, that one's pretty clear.
Good. Next is magnetic energy. Anytime current flows through a conductor, a magnetic field is created.
Even just a normal cable?
Yep, even a normal cable. We use that magnetic field in motors, transformers, relays, solenoids, and contactors.
So that's basically how motors and transformers work.
Exactly. The last one is mechanical energy. Motors turn electrical energy into movement.
Like pumps, fans, and drills.
Spot on. Now let's move on to voltage, current, and resistance. This is where Ohm's law comes in.
I always remember the triangle, but I still mix it up sometimes.
That's normal. Just remember the relationships. Voltage equals current multiplied by resistance. Current equals voltage divided by resistance. Resistance equals voltage divided by current.
And we use that for testing and fault finding.
All the time, especially in theory questions. Now, power. Power tells us how much energy a load is using.
Power equals voltage times current.
Correct. You'll also see current squared times resistance and voltage squared divided by resistance. These formulas are common in load and heating questions.
Yeah, those ones come up a lot.
They do. Now, resistance itself. Different conductors have different resistance.
Because of the material?
That's one reason. Copper has low resistance, steel has higher resistance. Length matters too. Longer conductors have more resistance.
And thicker cables have less resistance.
Exactly. Temperature also matters. As temperature increases, resistance increases. That's why hot cables behave differently.
Okay, that makes sense.
Next are resistor parameters. These are things you need to know when identifying or selecting resistors. Resistance value limits current. Power rating tells you how much heat it can safely handle.
If it goes over that rating, it can burn out.
Correct. Tolerance tells you how close the actual resistance is to the marked value, and temperature coefficient tells you how resistance changes with temperature.
All right.
Now, measuring instruments. A multimeter measures voltage, current, and resistance. A clamp meter measures current without disconnecting wires.
Insulation resistance testers check insulation quality.
Yep. Fault loop impedance testers check the earth fault path so protective devices trip quickly. And RCD testers check trip times and leakage current sensitivity.
Got it.
Next, how electricity is produced. Electricity is generated using electromagnetic induction. A conductor moving through a magnetic field creates voltage.
Most power here comes from hydro and geothermal.
Correct. Also wind and gas or steam turbines. They all spin generators to produce our 50 Hz supply.
Okay.
Now, simple circuits. A basic circuit needs a supply source, a phase conductor, neutral conductor, load, protective earthing conductor, and a control device.
Phase takes current to the load, neutral brings it back.
Exactly. The Earth provides a safe path for fault current so protection can operate. Switches and isolators control when the load is powered.
That helps with testing and fault finding.
It does. Now series and parallel circuits. In a series circuit, the same current flows through every component.
Voltages add together, and if one part fails, everything stops.
Correct. In a parallel circuit, the voltage is the same across each branch.
Currents divide, and if one branch fails, the others keep working.
Exactly. That's why lighting and socket circuits in homes are wired in parallel.
Makes sense.
Finally, basic DC calculations. Using Ohm's law and the power formulas, you calculate current, voltage, resistance, and power. These calculations appear often in theory exams.
Especially with heating elements and simple circuits.
That's right. So overall, this topic gives you the core understanding of how electricity behaves. Once this is solid, the rest of electrical theory becomes much easier to follow.
Yeah, I can see why this topic is so important now.
All right, that's a good place to wrap it up for today.
Yeah, that was actually really helpful. My brain's a bit full now, but in a good way.
That's normal, eh? Best way is to let it settle a bit. Maybe do a short review later or tomorrow rather than pushing too hard.
Yeah, I usually find after work I'm pretty cooked anyway. Might just skim my notes tonight.
That's perfect. Consistent little bits beat cramming every time. How's work been lately?
Busy, mostly domestic stuff again. Lots of heat pumps and switchboard upgrades.
That's good experience. Even though this theory feels a bit removed sometimes, it all links back eventually.
True, I'm starting to notice bits of it more on site now.
That's when it really clicks. Anyway, hopefully you can switch off a bit tonight. Maybe catch the news or see how the rugby's looking this weekend.
Yeah, might do that. Weather's meant to be decent too, I think.
Nice. All right, we'll pick it up again next time. Just keep chipping away at it.
Will do. Thanks, Mark.